All right, we're going to do chapter 8.5, which is systems of nonlinear equations. So before, we were just graphing lines and seeing where those lines intersect. So a system of nonlinear equations is combinations that do not have a line. Okay, so I could have two circles, or I could have one being a line but the other one is not, okay? So at least one of them is not a line. Remember that the solution of a system is where the graphs intersect. So we could do this on the graphing calculator as well, but we're going to look at the algebra behind it today. The easiest way to do these is by elimination first. So try that one first, and then if not, use substitution to solve these. Okay, so we're going to look at some types of intersections. Now, we could have many combinations of equations here, such as we've been talking about conics. So we're going to really talk about the circle, the ellipse, the hyperbola, and the parabola in combination with some others. So you've got, any of your parent functions that aren't aligned. So cubic, reciprocal function, step function, all sorts of functions. You could even do sine, cosine, tangent. That's kind of a different route that we're going to go to. Okay, so let's look at a parabola and a line. So I'll graph some parabolas here. Okay. So now if I take some line, maybe my line doesn't even touch it. Okay, that's one type of system I could have. My line could kiss it or touch it once. This is a tangent line to this curve and just touches it once. Or I can go totally through and my parabola and touch it twice. So in this case, I would have two solutions to that system. Let's look at a parabola and an ellipse. Okay. So again, here, maybe it doesn't touch it. Maybe it touches it once. Maybe it touches twice. This is kind of just the progression as this parabola comes into the ellipse. It could touch it 3 times. And this isn't the only way you could imagine these. There's some different ways that we could write this or draw this up. Or it could touch it, go through it 4 times. Okay, so that's a parabola and ellipse. We could have parabola and hyperbola. So if I draw hyperbola here. So let's just say maybe it doesn't intersect. Okay. Maybe it intersects once. Maybe it's kind of on the outside of that one. Maybe it intersects twice. And there. Could intersect 3 times. Right through there. And then maybe 4 times. Okay. Let's see if I can hyperbola and ellipse. So let me draw some hyperbolas out here. And these are just, some basic ones that we might look at. These are not the only ones that you can have. Again, you can have many different combinations. We could even throw a line in here and have 3 equations if we so choose to do. Okay, so again, maybe not, maybe once, maybe twice, maybe 3 times, and maybe 4. Okay, so different ways of knowing how many possible solutions are. Okay, so let's try one here. Okay, so we've got 2x minus y equals 3, so this is the line. And we have x squared minus y equals 2, and this is a parabola. So I'm trying to figure out how is this parabola and this line interacting. Okay, so I have a possibility of none, 1, or 2 solutions from those combinations we made. So remember, the easiest way here is to try to eliminate one of the variables. So I can't eliminate these because they're not like terms, but I can eliminate these. So if I subtract the 2 equations, that would leave me with 2x minus x squared. Those go away. 3 minus 2 is 1. Okay, here now I have a quadratic equation. So I'll get everything on one side. So I'll move it all to the right-hand side. So I have x squared minus 2x plus 1 equals 0. And then we'll factor. So any factors of 1 that add to 2, which are 1 and 1. Signs are the same, they're both negative. Okay, so this tells me that x equals 1 with multiplicity of 2, but we're not worried about the multiplicity in this case. So now that I know x, we'll take it back in here and we'll plug it into either equation to figure out y. It does not matter which one. So let's take the top one. So 2 times 1 minus y equals 3. So 2 minus y equals 3. So negative y equals 1. And y is negative 1. So at 1, negative 1 is where my line and parabola intersect. Okay, so this is actually a tangent line there at that point. All right, so in this one we have a parabola again, and in this one this is a circle. Okay, make sure you know the difference between circle, ellipse, parabola, and hyperbola, and all those parent functions. Okay, this one we can cancel the x squareds here simply by adding the 2 equations. So those go away. So you have y plus y squared equals 2. So get everything on one side again. So y squared plus y minus 2 equals 0. Again, factor. You'll notice that the process on this is the same almost for most of them that we'll see. So factors of 2 that subtract 1. It's 2 and 1. Signs are different. The bigger number is positive. So this tells me y is minus 2 and 1. So then we go find x and plug it into either one of these. It doesn't matter. Let's just do the bottom one here. So when x is minus 2, okay, so that's 4 plus y squared equals 9. Y squared equals 5. Y is plus minus radical 5. Again, when you take the square root of a variable, you need to make sure you have this plus minus in there. So I'll go ahead and write the ordered pairs for that one. So I got negative 2 and radical 5, negative 2 and minus radical 5. Okay, so then we'll plug in 1 squared plus y squared equals 9. So that's y squared equals 1 plus 9. That's y squared equals 8. And so we have y equals plus minus the square root of 8, which turns into plus minus 2 radical 2. So that goes with 1. So we have 1, 2 radical 2, and 1 minus 2 radical 2. So in this case, the parabola and circle creates 4 intersections. Okay, so let's just take a look at this here. If I have my circle, it's centered at 0, 0 here, radius of 3. So maybe looking something like this. This parabola would open up, but went down 7. So my parabola would, I don't know, be down here somewhere, opening up. Look. Opening up somewhere. Somehow like that. That's kind of bad drawing, but we get the idea of how those intersections work, or how those two graphs are related to each other. All right, so again here we've got a parabola and another parabola. We want to see how they intersect. The most they could intersect is 4 times. Let's say I got this parabola, and then I got another one going this way. So there's a possibility of 4 intersections there. So that's what we're going to figure out. So I will start by adding the 2 to eliminate my x squared. So that leaves me with 2y equals 8. So y is 4. So then we'll take that y value and plug it back into either one. Let's do the top. So I got x squared plus 4 equals 3. X squared equals minus 1. And x equals plus minus I. So my ordered pairs here are I, comma 4, and negative I, comma 4. Now, what's the problem with that is, well, these are imaginary numbers. So that tells me that these two parabolas will not intersect. So in this case, there are no real solutions. Okay. Yes, everything has a solution, and we found them, but they're not making my parabolas intersect. So we'll stop and say no real solutions there. All right, so here, notice the minus sign with the squareds and a 1. So that's going to be a hyperbola. Here I've got a plus, I got a 1, and I got a number over here. So this is going to be the ellipse. Okay, so I got a hyperbola and ellipse. So how are they interacting? So notice here I can cancel those by addition. So I have x squared over 4 plus x squared equals 2. Well, this is really 4 over 4. So you have 5/4 x squared equals 2. And we will multiply by 4. You get 5x squared equals 8. Divide by 5. X squared equals 8/5. So x is plus minus the square root of 8/5. So we've got x. So let's come over and find y. Just put it in this bottom one here, might be easiest. So the square root of 8/5 squared minus y squared equals 1. So this becomes 8/5 minus y squared equals 1. So then we'll subtract 8/5. So you have negative y squared equals negative 3/5. It's 5/5. So then y squared equals 3/5, and y equals plus minus 3/5. Okay, so we'll start my list here. We got square root of 8/5, comma, square root of 3/5. We got negative square root of 3/5. Sorry, I have the square root of 8/5 again, and the square root of 3/5 negative. So that was if I had positive radical 8/5. Well, if I put a negative in here, nothing changes after this, because a negative squared is still a positive here. So all that after there stays the same. So we'll just say negative radical 8/5, comma, radical 3/5, and negative radical 8/5, comma, negative radical 3/5. So this hyperbola, which is opening this direction, and this ellipse intersect 4 times here. How did I know that my hyperbola was opening that direction? Because x came first. How did I know my hyperbola was longer this direction? Because x had the bigger number. Remember, this one's over 1. So it's longer in the direction with the bigger number. So here's my solutions there. Okay, so if we got a circle here and a line, but if you notice here on this one, I can't cancel anything because I don't have like terms. So what I want to do is I want to take this bottom one and we'll just solve it for one of the variables. Now once I've solved it for that variable, we'll take it and plug it back into the other equation. And now we can solve this for x. So I have x squared plus, we will FOIL this out. So you get x squared plus 2x plus 1 equals 5. So 2x squared plus 2x minus 4 equals 0. I can cancel everything by 2. So you get x squared plus x minus 2 equals 0. Then factor. So you have x, factors of 2 that subtract 1, 2 and 1. Signs are different. The bigger one is positive. So you have x is negative 2 and 1. In order to find y, I can just take this equation right here and find out what y is. So y equals negative 2 plus 1, which is negative 1. So I have an ordered pair negative 2, negative 1. There's 1. And then y equals 1 plus 1 is 2. So then you have 1 comma 2. So if I got this circle here on my graph, 1, 2, that's there, negative 2, 1, that's there. So my line is intersecting about in there like that. As you can see from the line, we got a slope of 1, y-intercept of 1. So that kind of matches there. Okay, now again with this one, I can't eliminate anything because I don't have like variables. But this one again is a circle. And this one might be a little more difficult because it's not a conic section. But this one is the reciprocal function. And the reciprocal function looks like this. Kind of like the hyperbola a little bit. Maybe turn or tilted. Okay, so again, I'll take this one and we'll solve it for a variable. So let's say y equals 2 over x. So then I'll take that and put it back into the first one. So I have x squared plus 2 over x squared equals 5. So that leaves me with x squared plus 4 over x squared equals 5. We can multiply the whole thing by x squared because that's my common denominator, or my denominator here. So then we get x to the 4th plus 4 equals 5x squared. Again, that's just a different form of a quadratic, so we'll move everything to one side. It's 4 minus 5x squared plus 4 equals 0. We can factor that, but instead of putting x at the front, this time I'm going to put x squared. Factors of 4 that add to 5. It's 4 and 1. Signs are the same, they're both negative. And again, you should be able to recognize that those two are difference of squares. You got x plus 2, x minus 2 factored. And then you have x plus 1, x minus 1 equals 0. So that leaves me with x being negative 2, negative 1, 1, and 2. We've got 4 possibilities here. Now, to go find y, we got y equals 2 over x. So we're going to bring that down to figure out my other ones. So I have y equals 2 over negative 2. So that's negative 2, so that y is minus 1. We have y equals 2 over negative 1. So negative 1 comma negative 2. Y equals 2 over 1, which is 2. So we had 1 comma 2. And y equals 2 over 2, which is 1, to 2 comma 1. So that's where these two reciprocal functions in this circle is intersecting. So maybe something like this. Reciprocal function, the other side, and I've got a circle in there. 1, 2, 3, 4, intersection. Okay, so applications are really where we're going to use these system of nonlinear. So I've got one here. So a couple buys a rectangular piece of property advertised as 10 acres, which is about 400,000 square feet. They want 2 fences to divide the land into an internal grazing area and a surrounding riding path. If they want the riding path to be 20 feet wide, 1 fence will enclose the property and 1 internal fence will sit 20 feet inside the outer fence. The internal grazing field is 237,600 square feet. How many linear feet of fencing should they buy? Okay, so the first thing I want to do is draw a picture here. So I've got the property that they bought. Okay. And they're going to put this internal grazing area in here. Okay. And we know the distance from here to here is 20. You want the riding path 20 feet wide. So it's 20 on everything here. Okay. So let's say that this is X and this is Y. And they want this total area in here to be 237,600. Well, this is X, then this long side here will be x plus 40. It's this length plus the 20 on each side. And this one will be y plus 40 because it's the y length plus 20 on each side. And they want that area, or the whole thing, is going to be 40,000. So we're going to find here two equations. So we'll take x, y equals 237,600. That's for the inside. And that will help me find the perimeter here. And we'll take the outside to be x plus 40 times y plus 40 equals 400,000. So here are my two equations. I got two equations, two unknowns. I'm good to go. But let's reorganize this bottom one here because I don't like the way it's set up. So what we'll do is we'll FOIL this out. So we get xy plus 40x plus 40y plus 1600 equals 400,000. Now, I know what xy is. If I take x times y, that gives me this number right there. So we'll substitute that in. So 237,600 plus 40x plus 40y plus 1600 equals 400,000. Again, we'll move everything to one side except my terms. 40x plus 40y equals 160,800. Then I can go and divide everything by 40. That is 4,020. So there's that equation plus the original equation, or the top equation. So now I have these two equations, which is a little bit more friendly. So what we'll do is we'll take this top one here and we'll say y equals 4020 minus x. And we'll take that into the bottom one. So you have x times 4,020 minus x equals 237,600. I got one variable, I can solve it. So distribute 4,020x minus x squared equals 237,600. Get everything on one side. I like to move to the right side there to make that a positive. So you have x squared plus 4,020x. Sorry, that's a minus 4,020x plus 23,7,600 equals 0. So now we need to find factors of this large number that add to this small number. Well, easy way to do that is just graph this equation on the graphing calculator, zoom out to over 5,000 here, and then see where it intersects the x-axis. Okay, so if I factor that, or start making a list of factors if you want to do it the long way. So factors of this number that add to 4,020 are 60 and 3,960. Signs the same, they're both negative. So x is 60 and 3,960. Well, how can x be two numbers? I'm saying x is this one length, y is this length. How can this length be two different numbers at the same time? Well, it can't. Okay. What happens is I don't know if this is the short side or the long side. So it gives me options. It says, well, if you pick x to be the long side or the short side, then this has got to be the long side, which would be y. And if x is the long side, then y is going to be the short side. So really, you found your dimensions right there when you did that. If that doesn't make sense, come back up here to this equation right here. Okay, we found factors of this, which are 60 and 39. So no matter what, I'm dividing by that other number. So to go back up here and answer this question, let's just say that x is 60. So this side down here will be 100. Let's say y is 3,960. So this side would be 4,000. It says how many linear feet should they buy of fencing? Well, start here. I've got two sides that are 60. I've got two sides that are the 3960. I've got two sides that are 100. And I've got two sides that are 4,000. If I add all that up, I will get 16,240 linear feet. That's how much fencing they need to put up. But if I switch X and Y here, would anything change? No, because I still have 60 here and 3,960 there. So I still got those two. This one here will now become 100, and this one will become 4,000, which I got them there. So it doesn't matter. Yeah. All right. So here's your suggested problems. Okay. We'll take a quiz. If you got questions on it, please write them down and let me know. And we will take the quiz shortly. As always, thanks for watching.